thank you all for coming. It is a wonderful opportunity to see you over lunch and for your support of this fantastic organisation. And I say I'm blessed because I have the wonderful opportunity to lead it, but also to interact with lots of very bright and stimulating scientists. And you're going to hear from three of our young stars this morning. Not quite sure if you realise that philanthropic donations, such as the combination of things that you provide and donate to the Perkins, provides about 1 in 2 of all of our projects across the Institute. So it's a really, really valuable contribution. Can't in any way emphasise that enough. It's a huge contribution that you're currently making to the Institute in various ways. Some of you in the room are regular givers. Some of you in the room have already indicated that you'd like to bequest funds to the Perkins. So there's many different ways of supporting this wonderful place that we work. So look, from me, on behalf of our board, on behalf of our researchers, on behalf of our wonderful students, on behalf of our professional services who organised this, a big thank you to you all for your generosity, past, present, and hopefully in the future. So thank you. Now, some of you know the Perkins. I can see many familiar faces, but just very briefly, a little bit about the institution. We're on 3 campuses. This is the mothership here, but we have a second building down at Fiona Stanley Hospital, and we also have a group based at Royal Perth Hospital where we used to be before we moved into this building here. And we have 3 major programs of work, and we don't have huge numbers of different programs, and we're realising if we want to make a difference, we really want to make a difference to the outcomes of people across the globe, we've got to do less but more. So we have 3 programs. We have a cardiovascular and diabetes program, we have a genome biology and genetics program, and we have a cancer program. So 3 key programs. But if you think about it, the 2 programs of cancer and cardiovascular disease and diabetes make up most of the reasons we actually get sick as we get a bit older, and most of the reasons we actually die. So they're big programs focused on making a difference to people with those afflictions. And in particular, we're going to hear in a moment from one of our genome biology and genetics young stars. And in that program, there's this wonderful exploration and finding genes and linking them with human diseases. And it's really challenging, but super exciting when you get new results that allow you to say, with this young person in front of me, we now know what the diagnosis is, and we can actually go about finding out how to treat them. So it's a very exciting time. We've got about 440 people in the Institute. We are split up into the 3 programs, and inside those programs, we've got about 25 group leaders, each of whom is running their own small business, that being medical research. We write grants, we write papers, and the aim, of course, is to discover things and to push that discovery towards the bedside. And what I mean by that is that when you discover things, we want to translate them into new diagnostics, new preventive strategies, and new therapies. Okay, those 3 key things, because medicine's made up of those. We're not very good generally at actually preventing a disease. Up to 50% of all cancers are actually preventable, and I need to do my colon, my sort of poo test. That arrived in the mail the other day, and it's really important that I do that. And I haven't actually, I've been procrastinating for a week or 2, but I must bloody well get there and do it. Much as women, my wife works in breastfeeding. She's a physician working there, and she's seeing lots of women on a daily basis with breast cancer, which is potentially a preventable disease. So as is cervical cancer and of course melanoma. So prevention, diagnosis, and therapy are the focus areas that we have within those programs. Okay, and just a little bit of background, and it's really important. Some of you will know a lot about the Perkins, and some of you might not know quite so much. The lifeblood of this place is our young scientists. We want to make it a wonderful place for our young scientists. We started a fantastic initiative from the community development team headed by Paige Gibbs called Safe Harbour. Some of you might have heard about it or read about it on the web. And what Safe Harbour is about is it's providing 3 years of assured income, not for the lab head or the group leader, but in fact the senior people in the lab who are moving towards being an independent investigator, an independent researcher driving their own agenda. And so Safe Harbour is in fact providing them with a salary and some consumables for the laboratory for 3 years, and Perkins pays for those. And so we've recently announced 2 more, so we now have 3 Safe Harbour young scientists, young stars who are on their way to becoming a group leader and an independent researcher driving their own agenda. But we're really chuffed by how competitive it's been, but how successful our 3 awardees have been. And there's many other things we're doing, but Safe Harbour is specifically directed to providing stability for young scientists. We haven't yet heard from the National Health and Medical Research Council, who is our major national funder, of the results of this year. We actually know, but they're embargoed until the Minister for Health decides that it's a day that Mark Butler, would like to make an announcement. It might be a slow political day or whatever, but just to let you know that we actually did, and this is really important for you to know, we did really well this year in the granting, and we actually got something a bit less than 50% across the line, which is amazing because normally it's about 5 to 10% of our grants we write are successful. It's very challenging indeed. And it gets back to the generosity that you all show us that helps us. When you've got a grant that misses out by a smidgen, it allows us to do the work because we've got additional funding coming in. So and the last thing I wanted to mention before we get on and hear from our young stars is we were reviewed, and this is also important information for you. We were reviewed by a panel of 5 experts who came from all over Australia and one from the UK, from Oxford University. And this was in early August of this year, a couple of months ago. And all of the institute, the group leaders, we were reviewed by the panel of 5. Each of the lab heads had an independent assessment, and the whole of the institute and our science, its competitiveness, its ability to make a difference to human health across the globe, all of that was assessed. And you'll be pleased to know it's still not, it's an embargoed document, but it'll come out pretty soon. The take home was we're doing really well, growing really well. We are an international brand that's strong, and this has got a great future in this place, which is warming our hearts, warming the board's hearts, headed up by John Barrington. And you need to know this is a world-class institute operating in world-class facilities. And so we're really very pleased with that from an independent perspective. Now, that's enough from me, because what I'd like to do is introduce, after we have a video, 3 of our young stars who are going to give you a taste of the work that they are each doing in our 3 key programs. So I think we're going to have a video, is that right? Magnificent.
Hello, my name is Leon and I'm one of the many researchers who are funded by you. For the next few minutes, the staff of the Perkins will be sharing with you some of the discoveries you've made possible with your generous and loyal support of WA Medical Research.
25 years ago, in the basement of B Block at Charlie Gardner's, a bold plan was hatched to form the Western Australian Institute of Medical Research, or WAMR.
Jump forward to 2015 and we have gone from that to this to this.
Along the way, we changed our name to the Harry Perkins Institute of Medical Research to honour a man whose vision was to create a world-class place of science and collaboration.
Like you, Harry was a donor and a farmer from WA's wheat belt, a family man and a visionary. Sadly, cancer took his life before this place that's named after him was completed.
But his legacy is built into every brick of the Perkins, and his philosophy of collaboration, conducting research into the diseases that most affect our families.
Cancer, cardiovascular disease and diabetes.
And rare genetic diseases
continuing to this day.
25 years ago, we started with 3 labs, we had 6 publications, and the entire staff could fit into one picture. And here I am, in the middle.
And this is me here as a PhD student all those years ago.
And this is me, right here, with a whole lot more hair that wasn't grey.
Today, the Perkins has 426 staff and students.
Working in 25 laboratories.
And this year alone, we've published more than 164 different discoveries in over 50 different research areas.
Research has drastically changed in those 25 years, but one thing remains constant. Breakthroughs have happened because people like you backed incredible science, allowing it to advance at a lightning pace.
23 years ago, the human genome was mapped. It took 15 years and cost almost $3 billion. Since then, the Perkins has been instrumental in mapping dozens of genes related to hereditary diseases.
And we've provided clarity to hundreds of prospective parents who have been part of a pre-pregnancy disease gene screening.
25 years ago, when a patient came to a hospital with a heart attack, often the best that could be done was to put them in a darkened room, give them morphine and some lidocaine with the hope of preventing dangerous, irregular heartbeats.
Now, thanks to work being done right here at the Perkins, we have groundbreaking solutions for blood clots causing blockages. We have repurposed a well-known gout drug that is helping prevent heart disease, and we are working on a 3D printed heart valve that never needs replacing and works exceptionally well. And best of all, as of today, we have seen a near 40% reduction in death due to coronary artery disease since 1998.
Cancer research has made tremendous progress over the past 25 years. Cancer researchers like me have gained a deeper understanding of cancer biology, genetics and molecular mechanisms, paving the way for targeted therapies and personalised medicine. And breakthroughs in immunotherapy in the last decade have revolutionised cancer treatment.
The Perkins is at the forefront of developing treatments, devices and therapeutics aimed as personalised cancer treatments. This includes groundbreaking research into the use of naturally occurring anti-cancer treatments, such as bee venom, the development of a probe that will significantly lessen the need for secondary breast cancer surgery, and T-cell therapy that supercharges your own cells to fight cancer in your body.
But none of this would be possible without you.
Your foresight in funding the future health of families here and around the world means we can focus on life-saving science and not the business of research.
And that gives people like me enormous peace of mind.
You're providing equipment, expertise and job security for researchers who hold the key to unlocking how we treat this disease.
Every time you donate to the Perkins, you're ensuring that medical research goes on.
No matter what.
And when you donate your time or talent by volunteering for us, you're giving more than hours. You're providing invaluable assistance.
And when you acknowledge us in your will, you become part of a long-lasting legacy of giving that will impact the next generation and the one after that. When you help us, you also give yourself and those you love the opportunity to live longer, healthier and better lives. And you back the very best chance we have to beat the world's toughest diseases. From all of us here at the Perkins, a very warm thank you.
So I've got 3 wonderful young researchers that are going to tell you about their science. You're going to hear about their passion, what drives them. And the first is Dr. Adina Wang. And Adina works, she's a research associate, and Adina works in the lab run by Professor Pilar Blancafort. Pilar is a wonderful breast cancer researcher and molecular biologist, and Adina has been working with her for quite some time and is a wonderful person. So please welcome Dr. Adina Wang.
Good afternoon, everyone. Thank you for being here. And I would like to take the opportunity to thank the organizer to allow me to be here to share a little bit about what I do in the lab here at the Harry Perkins. So I am a breast cancer researcher, and as such, I study how we can prevent breast cancer from happening. 1 out of every 7 Australian women will develop breast cancer. That's on average, about 40 women will be diagnosed with breast cancer every day. Before I get into how I choose to become a breast cancer researcher, let me share with you about how I lost two dear friends to breast cancer. To honor them, I will describe to you how they have impacted my life. I met Diane Rashik about 12 years ago when I was embarking on a journey of soul searching. We attended the same classes for spiritual healing back in Malaysia. Diane and I had a similar quest at that point in time, and that was to figure out our role in this world. Diane learned that she had breast cancer, but that did not stop her from wanting to make a difference in the world. I was a student at that point, and I felt lost. I often wondered to myself, what is the purpose of life? What person do I want to be? What is it worth living for? Diane and I quickly became friends shortly after we met because of how much we could relate to, and we had so much common with each other. After we had completed the spiritual healing classes, Diane told me she felt more certain about herself and what she wanted to be. She became a spiritual coach to others. She taught people about how to embrace the moments spent in everyday life. Live mindfully. She learned that life could be fleeting, but what makes life a good one is to spend it in embracing the present moment, have no expectations, and to experience all that this human experience could give with an open heart. I thought about the people in her life and how unfair it was to them when they no longer have this wonderful daughter, sister, friend in their lives. I met Mikiko Aoki in 2005. She was a sweet Japanese lady who moved to Malaysia and became a Japanese language teacher. She's the reason that I can now speak an extra language and how to make sushi in the most authentic way. I remember her kind disposition and warm personality. She truly had a heart of gold. She also taught me to always chase my dreams. Her story of how she moved to Malaysia from Japan was that she met her husband through a foreign exchange student program. They got married shortly after, and she had to abandon her family and her dreams to be with her husband in Malaysia. During the marriage, she was unfortunately unhappy, but she refused to move back to Japan. This is because of her culture, her Japanese culture of shame, which is based on the idea that the act of violating certain social norm or expectation would bring shame to oneself or one's family. Towards the later years of her life, she grew so much smaller and weaker. We then learned from her daughter that she had breast cancer and it had spread to her lungs. Anyone is susceptible to breast cancer, even good ordinary people. People who are law-abiding members of society, and even those who has the biggest heart to share love and kindness to the world are susceptible to breast cancer. My hope for the future of my research is to find a way to eliminate and to prevent this awful disease from taking away any more lives of those who have so much to live for in this world. That's the purpose I live for. That is how I became a breast cancer researcher. So one exciting project that we are looking at in our lab is the potential of our very own Western Australian honeybee venom as a cure for treating breast cancers. So the honeybee venom is very, very potent, and in just a really small specific concentration, it can completely destroy cancer cell membrane within an hour. So within the venom, the key component is called melittin, which makes up about 50% of the weight. And what it does, it pokes holes on the cell membrane and disrupts it. So what we did then is to reproduce this component of melittin. And we found that this synthetic product was capable in killing specific forms of breast cancer, but it also affects the normal healthy cells partially. This makes sense because, as I mentioned earlier, the way melittin works is to poke holes on the cell membranes, so every cells are affected. When we use melittin in the lab, in combination with standard chemotherapy used in the lab, used in the clinic, it maximizes the effect to further reduce cancer cells from growing. So this suggests to us that melittin can be improvised and to make it more effective for the way it recognizes cancer cells and to target it directly. We are currently studying the optimum method of delivery of melittin, as well as toxicity and the maximum tolerated doses to bring forward this exciting finding into the clinic. Now, the work we do today would not have been possible without the generous support from each and every one of you in this room, as I am extremely grateful for the funds raised to support my research. I just want to highlight two key points that are particularly important for me as an early career researcher. The fundings I received last year from the Walk for Women's Cancer Awareness Program, it has provided the means to develop novel ideas and also test new concepts. It acts as a fundamental for us to continue the research. And taken together, this will hopefully provide a successful springboard towards bigger funds that we can secure to continue this kind of advanced cancer research here in WA. Being a part of the Walk for Women's Cancer Awareness Program, I did the 35-kilometer walk all in a day for 5 consecutive years. I am fortunate to establish some genuine connection with all the supporters. I remember one year when I was trying to complete the last 5 kilometers of the walk, which was the hardest. And one of the supporters came up to me. Her name is Marie Kelly. She said to me, "Let's do this together. I'm here with you." At that point, those words means a lot to me. So I would end this by saying, like, let's all play our part and do this together, and we could hopefully eradicate breast cancer in the near future. Thank you very much, everyone.
What a young inspiration. That's all I can say. I love it. Okay, it is my delight to introduce Ria Shah, who works, Ria is a PhD student, and she works in the laboratory of Dr. Elena Pardo, Elena is originally from Spain and has travelled, recruited her from University of Queensland a little while ago. In fact, it was Queensland University of Technology, QUT. And Elena is a biomedical engineer, and she is a 3D printing whiz. And in fact, she builds 3D printing devices, and up in the on level 6 there's lots of these devices, but one beautiful one that she's built. So she's a biomedical engineer, but she's passionate about human health. And her students, like Ria, who we can hear from, have got that same passion, but it comes with this biomedical engineer twist. So please welcome Ria Shah.
Hi everyone, thank you so much for inviting me to talk today. I do have a few slides to give you sort of a brief overview of my project, but before I jump into that, I kind of wanted to tell you a little bit about myself. and talk a little bit about my journey and how I got to Perkins. And I always think it's quite funny because it wasn't very straightforward in the sense of I always knew I wanted to be a medical researcher. And so I worked towards that. In fact, I'm actually quite a very indecisive person that's interested in a lot of different things. So I remember when I was in year 12, you used to get these like printed handbooks at every university that had all of the majors listed in there. And I went through each one for UWA, Curtin, Murdoch, and I had a lot of like sticky notes next to me. And I color coded the sticky notes for majors that I was interested in. So I think blue was something related to medical sciences. Green was sort of engineering, science, that kind of thing. I think pink was arts. So there was like law in there as well. Basically anything and everything. And I went to the careers counselor at the time with like a set of books this thick and more sticky notes than I could possibly count, and laid them down in front of him. And I'm never going to forget his face. Poor Mr. Crew. I don't think that's what he sort of signed up for. So yeah, I was interested in a lot of different things. And I went to a UWA open day with my family, and my dad actually found a tiny little pamphlet that said, introducing a new course, biomedical engineering to UWA. And he said, you know what, you're mostly confused by engineering and medicine. So this kind of seems like a combination of the two. Why don't you look into this? And so I did. And then I Googled biomedical engineering jobs, Perth, and nothing came up. So then, I decided to do finance as my second major, because I thought, worst comes to worst, I can get a job in finance, right? So I did my undergrad majoring in both biomedical engineering and finance. And at the end of it, I thought finance was all right. But I thought biomedical engineering was really interesting. There were so many different topics that you can go into it. It was really broad, and it was this really new emerging sort of field. So I decided to continue with biomedical engineering. I did my master's at UWA as well. And as part of your master's, you do a small research project. So that's when I approached Elena and I asked if she had any projects available for me. And she sort of pitched me this idea of saying, we're not really working on any of this at the moment in my lab group, but I think it's a really exciting project. There's a real clinical need for it as well. And I think it would be perfectly suited to you. So I did my research project in my master's. I really loved the project, but also I loved my supervisory team. So Elena, she's just a wealth of knowledge. And I was also really fortunate to also have Shirley Jansen as my supervisor as well. And she's a clinician. She's actually the head of vascular and endovascular surgery at Sir Charles Gardner Hospital, and she heads up the cardiovascular program here at Perkins. So for a biomedical engineer, you have access to sort of an amazing engineer, an amazing clinician, and you can get kind of both perspectives of the problem, which I think is really quite unique. And that's kind of what drew me to doing a PhD here. So I've got a few slides to talk about my PhD. My PhD focuses on venous valves. So in the veins all throughout your body, they're incredibly important because that enables the blood transport back to your heart. And one-way valves open and close like this to enable blood to flow all the way back to your heart. So what you can see here is the calf muscle contracting as you walk. As it contracts, the valves open and close. So you can see that the valve's closed here, and this prevents blood from sort of pooling at the bottom of your legs. When these one-way valves don't work properly, what you get is this kind of effect here. So because they're not shutting, blood's sort of pooling in the bottom of your legs, and this can lead to really bad ulcers and chronic pain as well for people that suffer from chronic venous insufficiency. And this is a problem in all veins when you've got these valves that are incompetent and they don't work. But it's particularly a problem in the deep venous system because there's ways to treat the superficial system. You can basically sort of close off the superficial vein, and then blood is redirected to flow through veins that have competent valves. But in the deep system, these are veins that are located inside your muscles, and these are much larger veins that are predominantly responsible for your lower limb sort of blood outflow back to your heart. So when the valves in your deep veins don't work, there's currently no existing efficient treatment methods to solve this problem. And people have looked at developing sort of a prosthetic valve to be implanted so that you can get valves that are working properly in the deep veins, but these have all failed in the past. So there's currently no successful commercially available prosthetic venous valves. Now, where we differ is we specialize in advanced technology and materials. So we have access to things that have never been tried before, which puts us in a really unique position to be able to tackle this massive problem. So as Peter was saying, we focus a lot on advanced 3D printing technologies. So what we have is a technique called melt electrowriting. Now that's a combination of two different types of techniques. And that enables us to create these kinds of scaffolds. So you can have all kinds of different patterns, different architectures, different shapes, and in a range of different sort of patterns there as well that you can see here. And this is on such a small scale. So we're looking at sort of tens of times smaller than a millimeter. And now what we can do is look at what the native tissue, what natural venous valves are actually made of, and try to replicate that with our 3D printing technology here. So what we can do is look at different fibrous structures in the venous valve leaflet. So what you're looking at here is collagen that's predominantly responsible for the strength in the venous valve leaflets, and elastin. So that is what causes the valve to sort of recoil back, like you can see in the video. And it's both of these that are really, really important to make sure that the valve opens and closes the way that it should. So what we can do is look at what the valve is made of and try to replicate this with our 3D printing technology that we have here in the lab. We also are really fortunate to have access to state-of-the-art technology when it comes to a flow loop as well. So what you see here is a test that we did actually up on level 6. So this is our own valve that we've created and designed. This is specific to heart valves, so I'm hoping to do something very similar for my venous valves as well. And we can actually test it in this state-of-the-art flow loop. This technology, the Vitro one, is particularly used to test new devices, and it's actually sort of the gold standard, the benchmark device that's used. So what I'm hoping to do is generate new knowledge, progress the field of venous valve prosthetics, and we're working towards developing a novel, effective treatment option for so many patients that currently they just have to suffer because there's no existing treatment methods for this. All of this is only possible because of the support that we have here and how we're so fortunate here at Perkins to have access to all of this kind of technology, thanks to supporters like you.
How wonderful. I love looking at that valve. It's really cool. Just think how many times it beats. Our last speaker is Dr. Josh Clayton, and Josh is a research associate in the Genome Biology and Genetics program. So we've heard from the two other programs previously. And Josh has been working in the rare disease and genetics and functional genomics, the lab of Professor Nigel Lang. And some of you might have heard Nigel speak. He's a fabulous speaker, great researcher, and fantastic mentor, actually. So, Josh, it is a great pleasure to introduce you to tell us about some of your work, please. Welcome, Josh.
Thank you, Peter, and thank you everyone for coming along. I remember the first time that I sort of really engaged with donors was last year. I got invited to speak and I was a little bit nervous about doing that, but it was sort of a bit of a sit-down lunch after as well. And I actually found that to be really nice. Sometimes as a scientist, you're talking to other scientists constantly, and I don't know, sometimes you can get a little bit down on the work you're doing. Maybe things aren't working, but it is actually really nice and lovely when you actually get a chance to talk to people and you get that enthusiasm back. And I don't know, kind of reinvigorated me a little bit where I was like, oh, this is, yeah, nice to hear. A bit about me. I grew up here in Perth. I've had a very boring, I guess, trajectory of science where I basically was born here and have lived here and continue to do things here. That's not to say that I haven't also had opportunities to go to other places and learn things, which I'll get to later. But I guess one of the things in science is it is sort of encouraged that you do go around to other places and learn new skills, which I have done. But really for me, one of the challenges that I had was that I have a really strong, I guess, connection with lots of friends and family here. And so for me, that's something that I really value and something that I think is often underestimated, particularly in science, where like having that sort of support is actually really beneficial to you being able to succeed in whatever you do. So yeah, I basically, my journey, I guess, has been, I did similar to Ria, I kind of wasn't really sure necessarily what I wanted to do, kind of enjoyed lots of different things, was always really curious, really enjoyed science in particular. So I went through university, did honours and then PhD. And then after that, I joined here at Perkins, and I've been here for nearly 6 years now. I actually started covering for someone part-time as maternity leave cover. And then now I've been here for so long. So I guess that's, yeah, partly just because I really enjoy the place here. So I guess why did I pursue a career in science? So again, I really did love science in particular at school. Then at university, I still kind of wasn't really sure. Did genetics and just really loved the lecturers and the content and stuff there. So that's kind of just, yeah, what I just became really passionate about. Then kind of beyond that, what I really grew attached to as I did honours and kind of came more into sort of the research space was really the people and the environment that you kind of work in. So like a lot of the people that I've kind of worked with are really sort of similarly minded, and it kind of just makes a really nice environment to work in, where you can sort of see other people are passionate about it. Other people are always really willing to offer ideas and suggestions, and that for me was really great. And then kind of since coming to the Perkins, the work that I've done, I guess also like it has a really clear impact on people, which is something that I kind of lacked when I was doing my PhD. I kind of got a little bit disillusioned. I was sort of like, this is good. I feel like I've learned stuff, but I don't really see like where this goes. And so for me, that was a really difficult point in my career. And then since coming to the Perkins and working with Nigel and his team, that kind of, you know, sort of reinvigorated me. So you've probably seen a few of these faces. Peter mentioned Nigel. So he's I guess the leader of our group, has been doing genetics in WA for 35 plus years. And as Peter mentioned, like he's been a really good mentor. So the main thing, I guess, that is currently leading, I guess, is genetic carrier screening. So our group basically on the whole looks at rare diseases, so predominantly rare muscle diseases, nerve diseases, brain diseases as well. Basically, we want to know what is the cause of that disease, and then can we then come up with ways of eventually preventing or treating that condition. So Nigel leads carrier screening approaches, which are basically to look at couples, work out what potential risks do those couples have of potentially having a child with a really severe condition. And then basically what that does is it then gives, I guess, people options about what they want to do moving forward, and is kind of about just giving them knowledge about, what things they could come across. Gina, who I guess, so she also works under Nigel, but now is sort of her own group leader, which is great, and she's also been a really good mentor. And her work really focuses on, if we know that people have a really severe condition, how to actually go through and work out what is causing that. And that's because all of these sort of rare severe conditions are caused by often just a single change in our DNA, and that's enough to basically cause disease. So we kind of know that there's something that we can find, and once we find that, then we can basically go from there. But there's a real challenge in finding something that you don't know, and kind of saying, yes, this is what we know is the cause of that disease. And lastly, the team that I work in is kind of under all of that, is with my friend who I've worked with in science for probably more than 10 years, Rhonda Taylor. And she really drives sort of the next part of that. So it all kind of fits together. She's basically trying to make models that we can use to basically test and develop new treatments for these diseases. So it kind of goes the full spectrum of screening people, identifying the cause in people that have these diseases, and then how can we go from there to actually treating them, which I'm really passionate about. So again, one of the things that I really sort of have enjoyed about being at the Perkins is that a lot of the work the Perkins does, but our group, but also the Perkins as a whole does, is it really has a sort of clear translational goal. And so I guess the work that I do in particular has the real potential to actually improve the lives of people and patients with these severe diseases. And the photo that I've got up there is actually a sort of conference that my colleague Rhonda went to last year, which is a sort of hybrid conference which involved patients. So you can see there's a lot of people that are in wheelchairs, which are these people with these really severe muscle diseases, which basically mean that they have a really hard time breathing and moving and really struggle with a lot of day-to-day stuff. So I guess things like that also really help, I guess, instill in us a lot of passion, because you can sort of see what these people are going through. And then I guess that kind of gives you a bit more of a drive to go, well, that's actually something that's really worth fighting for and trying to do what we can. So so the work that I do to basically kind of address this lack of treatments for, I guess, these conditions, I work a lot with a thing called stem cells. So historically, I guess mice are often used as a model for disease, and where that's kind of going, I guess, is that those will still be useful, but actually can we use human cells and use that as a model so that we don't have to necessarily go to those systems, or we can go to those once we have a really good idea that we've got something that really has good promise. So what I do is I take patient samples, so it's going to be skin or blood, and then I turn those into a different type of cell called a stem cell, and then I can actually then use those and turn those into muscle cells. There's a video of some muscle cells that we've made from these stem cells that actually fuse into these long muscle fibers that you would have in your muscles, and you can see that they actually contract by themselves in that context. And then kind of where we're going in future, that we're working with a few people from the US and also over East Victoria, are sort of 3D systems where we can actually take these muscle cells that we've derived from patients and actually grow sort of a 3D muscle. And we can actually use these to measure how well these muscles contract. And basically then that kind of creates a platform then for testing and developing new treatments, where we can say, well, this is the dysfunction that normally exists in those muscles. If we add this thing, can we rescue that to the point where the muscles are contracting properly? And that's obviously, again, a really good indicator of something that's working that we could then take to the next step to actually treat people. So Peter alluded to this, but where I guess the support of people like you is really important is funding is really difficult, particularly for people like me that are young researchers, where way back when, I guess the success rates were a lot higher. And so that kind of meant that, if you miss out 1 year, you've got a decent chance of getting funding the next year or the year after. Whereas now that's kind of dropped, where boring graphs, I know, but this is one of the sort of big funding schemes. You can see that even sort of over the last 8 years, the number of successful applicants has dropped from 646 to 248. And the success rates have likewise dropped from 17% to 10%. So it's both a reduction in like the proportion, but also the number. So, and that's, I think, also a factor of the fact that a lot of science is getting more expensive as well. So like to do the things that you need to, you kind of, I don't know, a lot of people will miss out, even if you've got something that's really, really good and really less funding. So Peter mentioned this before, but one of the really great initiatives that's happened at the Perkins over the last couple of years, which is, again, basically almost solely due to donor support to the Institute, is the Safe Harbour Fellowship Scheme, which basically gives, as Peter mentioned, salary for 3 years for an early career researcher, and also some costs to do their research. And where this is really good is it, I guess, gives a bit of security, but also sort of gives sort of younger researchers a chance to kind of really go off and potentially explore some of the work that they're really interested in that maybe is a little bit different to what they would have to do if they were working just under a big group with doing a particular funded project. So that has been really excellent. The other thing is, I guess a lot of the money also, I guess, goes to travel and things like that, support people like me to go overseas. So I mentioned before that I've kind of stayed in Perth, but I have actually had really good opportunities to go to the US, to Victoria and various other places to actually go and train and learn new things, which I've then brought back to the Institute, which has been really great. And then lastly, I guess this is kind of a bit more of an overview thing, but I think sometimes as researchers you get a bit caught up going, well, money should be coming to us to support the work that we do, but actually it's much bigger than that. And I think that's one of the strengths of working in an institute like the Perkins, is there's actually so much other support that really helps, I guess, free up a lot of our time to really do the work that we want to do. Yeah, there's admin staff, people that help us sort of engage our work with people like you, lab support staff, people that take care of the building and the equipment, and then also the Biodiscovery Centre, which is a really, really great part of the Perkins, which really is about sort of bringing really young people into sort of a research setting and giving them a real taste for what science is like and how that goes. So basically, there's a lot of things, and just overall, yeah, I want to say thank you, because it really goes to a lot of things and really is appreciated. So thank you very much.
three fabulous talks from three young, inspiring and exciting young scientists. And hopefully that little three vignettes gives you a bit of a window into some of the things that we do.